Hi, my name is Matthew Yakov, and today we're going to talk about network obfuscation by Versa Networks. First, let's review what kind of problems network obfuscation allows us to solve, and then we're going to review the mechanisms which we use to solve them. The first problem that we have to solve is the company merger. Imagine that you have a company which is called Acme, you have your own domain name, you have your own internal address space. Let's say that it's 172.16.00/24 and all of your servers are in this location. But then, imagine that company Acme acquires company Beta. And company Beta coincidentally have the same, absolutely the same address space, 172.16.00/24. So what in this case we have to do to connect these two networks together so they can operate even though they have overlapping IP addresses? For this we can use network obfuscation. Use case number 2. Reconnaissance attacks. Let's say that you have your remote access clients which is connected to the Versa Cloud Gateway, and you want to make sure that this client, if for example your company account will get to some intruders, that they will not be able to understand what are the actual IP addresses inside of your network. So this is use case number 2. Use case number 3. Imagine that you have company Acme, you have the cloud gateway through which you're connecting to that Acme, and you have remote users which are connecting to your company. If it's only one company, then we don't see any problems. But what if you have more than one company which needs to be accessed through the same gateway, and you have similar problem to the use case number 1, when you have two companies which needs to be accessed through the Versa Cloud Gateway which have overlapping IP address spaces. In this case, once again, we can use network obfuscation to solve this kind of problem for our customers. Now let's review how we can actually solve the problems and what are the internal mechanisms of the network obfuscation that we use. First of all, network obfuscation uses combination of the netting and dynamic DNS. All the CGNet mapping are based on the DNS responses that we receive. We can of course generate the new IP address which is going to be given to the customer, and therefore obfuscating what is the internal network of the other side of the network. Of course, it allows us to protect against the attacks such as reconnaissance attacks, so nobody can scan your network and know what is actually inside of their network. And also it allows us to merge different companies which have overlapping IP address spaces in their networks. Let's review in a little more details how it works internally. The mechanism is actually pretty simple. So imagine that client which connects to the Versa Cloud Gateway sends the DNS request that he wants to access mail.acme.com. When Versa Cloud Gateway sees this request, we can intercept all the DNS requests and we can generate the new request which we specifically want to send into the Acme network, because we know that it's based on the Acme domain and we know which of the internal companies DNS and domain name servers we need to use. So we're gonna send it to the Acme DNS and we'll find out that actually the resolution came for the mailacme.com, and mailacme.com was for 172.16.0.212, for example, or 25. So the Versa OS device, which is located on the Versa Cloud Gateway, will generate dynamic IP address which will be given in the DNS response. So in the response, we will reply not with the IP address that was received from the acme.com, but with the dynamically generated IP address from the cloud gateway. And this address is going to be given to the client to have access to. And at the same time, we dynamically generate the CGNet translation from the newly generated IP address to the internal IP address of the client. To make it even more crystal clear, let's review the following use case in more details. So on the left you can see Versa SSE client, which can be installed on any laptop. On the right you can see the customer destination and the Versa Cloud Gateway in between them. And by the way, network obfuscation can be configured anywhere. It can be configured on the regular SD-WAN, or it can be provided by the remote access service. But anyway, so the client sends request to the DNS server, which is the Google DNS server 8888. We intercept this request and we look inside of the DNS request. We see that it's coming actually to the acme.com domain name. So the Versa system will generate its own DNS request to the internal domain name server. internal domain name server may say that, for example, mail@acme.com is actually located at 132.16.0.25, and this is the reply that will be returned to the Versa device from the customer network. Next, what is happening? Device will generate its own DNS reply saying that the actual IP address for the mail@acme.com is not 132.16.0.25 but 10.0.0, for example, .10. And the last octet can be anything, so it can be arbitrary value generated every time due for every customer. And this will be returned to the client. At the same time, system will generate twice CGNet translation rule. So when the client will actually send requests from its IP address to the 10.0.0.10, which was dynamically generated by the VOS device, the actual packets that will go next will be going from the internal network of the customer to the internal network of the customer. So we are changing both source and destination IP addresses, and this way we are protecting users from exposing the IP addresses of their internal network and allowing to coexist for multiple networks simultaneously, even if they have overlapping IP addresses. I hope this was informative for you, and thank you for watching.